Hi, welcome back to the section 3 of the course Learning ECMAScript 2017. This is a section where we begin our exploration on the ECMAScript 2017 features. In this section, we will start off by looking at getting the Babel compiler to automatically compile or transpile your JavaScript code and run them from Visual Studio Code. We will then start exploring some of the basic features of ECMAScript 2017 like the new string functions like pad start and pad end, the entries and values function of the object class, trailing comma in object and array literals, and finally look into the object's getOwnProperty descriptors method. Let's begin with the string padding function in ECMAScript 2017 first. In this video, we will be looking at configuring Babel to transpile ECMAScript 2017 code and then have a look at the pad start and pad end function in ECMAScript 2017. In one of the videos in the section 1, we saw how to set up Babel in Visual Studio Code and transpile your basic ECMAScript code manually. Let's automate this process a bit in Visual Studio Code. We also need to generate source maps that will allow the node debugger in Visual Studio Code to map the breakpoints between our source and the compiled code in case you wish to debug your ECMAScript code within Visual Studio Code. Let's make Babel to keep watching our code for changes and recompile as necessary within Visual Studio Code. To do this, we need to add the compile script to your package.json file. This script would transpile the code in the source folder and output the results to the lib folder. The source maps and the watch options instruct Babel to generate source maps and continue watching the source files for any changes and recompile whenever changes occurs. Let's start the Babel compiler using the command npm run compile. And now it's time to add a Visual Studio Code launch configuration in order to run your application in debug mode. In the menu bar, click Debug and Open Configurations. And then add the program and the output files as shown here. So in this case, when we launch the application in the debug mode, hello.js would be started. The type and the request options in this configuration indicate that we will be using node.js to run your ES 2017 application, and VS Code should launch it for you. The program specifies the entry point to your application, and the out files specify where Visual Studio Code should find the compiled files, which would actually be used during the execution of your program. The source maps will allow the editor to map the compiled ES5 code back to your ES7 code. Let's go ahead and set a breakpoint in hello.js file and try to start with debugging option. Before doing that, let me add a simple line to display something on the console window. And when I add a breakpoint and then click debug and start debugging, you should notice that the breakpoint hits during the debug mode. To continue to run from this mode, click on the start button or a continue button. Let's jump onto the pad start function in ECMAScript 2017. This method prefixes the receiver with the fill string until its length is max length. For example, using pad start method with the receiver string p with the fill string of es and the max length of 5 will result in ESESP as shown in the slide. Let's jump onto some quick demo of the pad start method. I will be updating the hello.js file with the demo code so that the Babel automatically watches and transpiles my code based on the configurations made earlier. Like mentioned earlier, this method prefixes the receiver with the fill string until its length is max length. I will define a string p as receiver with the max length of 5 and the fill string as AB and display the result in the console. When I run this code, you should see the result as ABABP. Similarly, if necessary, a fragment of fill string is used so that the result's length is exactly max length. For example, if I change the max length to 4 and the fill string to be AB, when I run this, I should see the result as ABAP. If the receiver is as long as or longer than max length, it is returned unchanged. For example, if I change the receiver to be packed and if I set the fill string to be test and the max length as 4, and when I run this, I should see the result as packed. If the max length and fill string length are the same, the fill string becomes a mask into which the receiver is inserted at the end. For example, if I change my receiver to be pack and a max length of 10 with digits ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When I run this, I should see the result as 0, 1, 2, 3, 4, 5, 6 and then filled with the receiver. Pad end is the next function that we will be looking into. It works similar to pad start function, but instead of inserting the repeated fill string at the start, it just inserts it at the end. Let's jump onto Visual Studio to see the pad end function in action. Let's specify the receiver, fill string and the max length for the pad end function. When we run this, you could see that the fill string AB is padded to the end of the string P and the result being PABAB. In this video, we looked at quickly configuring the debug and allowed Babel to watch for any changes in JavaScript code and compile it or transpile it automatically. We then looked into the pad start and the pad end function, which was new in ECMAScript 2017.